All right, the sound seems to be on. Hello, everyone. I'm Mykola.
And I'm Cezary. Hello.
First things first, take advantage of the Dory Q&A feature in your Cloud Next app to ask questions that you might have during the session and to vote for the questions that sounds interesting to you. And in the end, we'll take a little bit of time to answer some of the questions on the top. So please raise your hands. How many of you run workloads on multiple virtual machines? Well, the majority of people. And how many of you do any kind of batch computation on multiple machines? Also quite a few. And how many of you have at least one virtual machine on Compute Engine? Pretty much most of the people. Awesome. So let's see how it works. When you deploy a new application, you would probably start with one machine, deploy application to this machine, test it, run it, and you might have a few users. This setup is quite easy to manage manually, or maybe not that easy. How do you know what machine type to pick? How much CPU or memory do you need? You probably could take the same machine size as you use in your on-prem data center before, but Compute Engine allows you find a granular configuration of how many CPU cores or how much memory you can pick. There is a good chance that there is a machine type that is just as well fit for your workload, but is smaller and cheaper. How do you know that you don't waste money? And once your workload grows and you get more users, you will need multiple machines to run it. This is where all kinds of problems might start, and it is no longer feasible to manage this type of setup manually. Let's look at what kind of problems those could be. First of all, your application might stop responding or crash. Some of the users might experience interruptions or latencies in your service. Another problem is, in a rare event, a whole zone might fail. And if you have deployed all your machines in a single zone, your customers might experience complete outage. This is not something that you want to experience. Or your load might spike and land on insufficient number of VMs. And the extra customers that you have, again, might experience longer latency or not be served at all. Something you don't want to happen. Or maybe you have provisioned enough of the machines to serve even your highest peaks, but then what when the weekend comes, for example, and your usage drops? You don't want to overpay for all those extra machines that are sitting idle. And on top of all of that, you will probably continuously improve your application and run all kinds of updates, security patches, new features. How do you roll out the updates safely and avoid the disruption in case of a bad update for your users? When any of these problems happen, you don't want to get paged, especially in the middle of the night. Because when coming to cloud, you expect your infrastructure to run flawlessly. And the good news is that managed instance groups on Compute Engine allows you to take care of these problems automatically and build you highly available, scalable applications where you can roll out updates automatically and safely, and also pick the optimal size of the machines for your workloads so that you can have a peace of mind knowing that your application is taken care of. In today's session, we will look how to deploy an application to a managed instance group. We'll build a stateless load-balanced application. And we will also look into how to apply VM right-sizing recommendations to those machines. And if you're already familiar with some of this concept, we'll have pro tips for you. So let's start with the application deployment. You likely have some kind of CI/CD pipeline, which results in an artifact. You could package your application in container image, or perhaps pre-bake it together with all of the dependencies on a boot disk image, or maybe write a startup script on top of a plain vanilla operating system so that it loads and boots your application on VM start. Any of these approaches work with what we're going to talk about today, but for the sake of example, let's pick container image. Deploying container image is easy on Compute Engine and takes only 2 steps. You create an instance just as you would any regular VM. You click the checkbox that you want to deploy a container, specify which container to run, and some of the parameters. Let's say start a restart policy, or you could pass some environment variables to your container. And what happens is that Compute Engine will create virtual machine based on the container-optimized operating system image, which already has Docker and container startup agent pre-installed. And it will boot your container on VM start automatically. You don't need to write any startup script. And on top of that, whenever you create a new machine, you could use the latest version of the container image with all of the updates and security patches that are managed by Google. So if one machine is not enough, you can also deploy your application to multiple machines in a managed instance group. So the way you do it is that you create instance template in exactly the same way as it's for virtual machine. And then instance template is like a recipe for creating a machine that managed instance groups uses to create your VMs. And if your application is load balanced, you can add your instance group as a backend service to a load balancer. That's it. So let's see how it works.
OK, so first we need to create an instance template. Before the presentation, I've uploaded the container to the container registry. You can upload it using Docker push command or just manually if you want. So let's copy the full repository name. Now let's create an instance template. Container. Let's put the URL. And also, let's allow HTTP traffic to the container because we have a simple web server application running in this container. So we can verify that it's accepting traffic. So right now, we have to wait 3 seconds for the template to be created. And once it's done, we can start and create a managed instance group using this template. So let's call it container. We can deploy it in any zone you want. We can turn off autoscaling for now. We'll handle this later. And let's create. So right now what is happening is Google Compute Engine is creating managed instance group that will manage all your instances within this instance. And right now, you see that it's already created. And you can see that there is a new VM that it's starting. So once it's being created, we can verify what is happening inside. So let's go to the VM. Let's go to the console. And you can see all the commands that are running during the VM. So it's being set up. The IP is being applied to the VM. So OK. We can also see right there. Not yet. Let's refresh. So what is happening in the background that our VM is pulling the container. You can see it right here. It's pulling the container from the registry. It's starting. And once it's started, it will boot up. And we can verify that it's working by entering the IP address in the URL. And we can see that it's up and running and serving our web application within like a few minutes. Back to you, Mykola.
Thanks.
Can we get back to the slides, please? Thank you.
Yeah. So we have deployed a simple stateless application to an instance group. But now, how do we make it highly available and scalable? But let's first talk about what a stateless application is. A good example of it would be, for example, a front end of a web store. You want it to be highly available so that your customers don't get HTTP 500 during checkout process. And you want it to be scalable so that you can get all the business you can even during the spikes, such as on Black Friday. And stateless VMs are like a herd of sheep. You care only about how many you have. You can easily replace one with another. And the machines work exactly the same way, and they don't carry any state on them. So let's go back to the problems that might happen. What if application stops responding or crashes? I see you have a question there. Could you put it on a Dory, and then we'll address it in the end. So If the application stops responding or crashes, auto-healing will help to take care of that. It will automatically recreate the instances, detect that they have, it will detect that they have failed, and automatically recreate them to keep them in service, so that your customers can be served again. Configuring auto-healing is easy. All you need to do is to create a health check and attach it to the managed instance group. And the way the health checking works is that it pings your application on a regular basis on a specified port and protocol, let's say HTTP 80, on a path that you show. And it will expect HTTP 200 response that everything is OK within a predefined latency that you can configure. And if the health check fails multiple times in a row, and again, you can configure how many times this is, let's say 2 failures, then the instance is deemed unhealthy, and auto-healing will kick in to recreate it from the instance template with the well-tested configuration. And health checking works for both HTTP, HTTPS protocols, as well as TCP and SSL. What's important to note is that you can create exactly the same health checks for load balancing purposes. And load balancer uses health checks differently than managed instance groups. When the VM is marked as unhealthy, load balancer does not send new traffic to the machine and will send it to the other machines that are still healthy. At the same time, managed instance group will recreate a machine that is unhealthy to bring it back in service. These are very different actions. And for that reason, we highly recommend you to create different health checks for load balancer and for managed instance group, and make it health check more aggressive for a load balancer. More aggressive meaning shorter check intervals, expect lower response latency, and maybe lower number of failed health checks to actually mark it unhealthy. This is important because imagine a situation when you have a machine that is serving at its full capacity, so it cannot really receive more traffic and will produce latencies. You want the load balancer to redirect this traffic to other machines. At the same time, the machine is perfectly healthy. It's serving existing connections. So you don't want the auto-healer to kick in and recreate it. So to make sure that in such situation your machine is not recreated, you should give auto-healer a little bit more time for the machine to recover and start serving again. Or if it's really unhealthy for a longer period, only then recreate it. That's why you need 2 health checks. Another pro tip is that when you configure auto-healing, make sure you set initial delay to a higher value than it takes for your machine to start. During the initial delay, auto-healing will not touch unhealthy machines to give enough time for the application to boot. Of course, while VM is booting, it will be unhealthy because your application is not yet serving. So if you set initial delay to longer than it takes to serve, you will make for the application to start serving, you will make sure that auto-healing will only recreate a machine when it is really unhealthy and not because it's still booting. So let's see how auto-healing works.
All right. So we have an instance group with 3 VMs up and running. All of the VMs are running the same web application. This is a simple Python script. It has a few features. One of the features is reporting the health status of an application. So if we click here, we can verify that our application is up and running. It's serving HTTP 200 response. So it's basically saying to the managed instance group that, yes, I'm OK. I can accept traffic, and I can serve traffic. So what I did is I created a simple method that will just start reporting unhealthy status. So what it means is that once I open the same URL, it's basically saying, I'm sorry, I've crashed. I will not accept any. I should not accept any connections right now. So it's telling managed instance group that this VM is not responding. The application is not running, so it should be recreated. So let's go here. It usually takes a minute or 2 for the managed instance group to notice it. So let's go and look how the health check is configured. So we've set up the health check auto-healing. So let's go to the health checks. Auto-healing. So we can see that it's looking at the path /health. So it's the same that I've used previously. It's using the HTTP protocol on port 80. It's pinging the application every 5 seconds. And it's waiting for 2 consecutive failures to notice that it's unhealthy. let's go back to our manage instance group. Auto healing. And you can see that manage instance group detected that application crashed and that the VM should be recreated, and it's already recreating. So after a minute, it will be up and running, and your traffic and your VMs will accept traffic, and everything will be fine. Can you switch back to the slides, please?
All right. So we have just protected our application against failure on a single machine. But what if there is a more rare event when there is a misconfiguration or something happens and the whole zone is out? Auto-healing will not help you with that, because even if it tries to recreate the machines, the problem is not on the machine, it's on the zonal level. So in order to protect your workload against that, you can deploy your machines to multiple zones in the region using regional managed instance groups. And in this example, the way it works is that even if a single zone fails, the load balancer will send traffic to the other zones where the machines are still available, and your customers will still be served. It's worth noting that on this picture, though, that you lose 1/3 of your capacity. So let's say if you need 9 VMs to serve all of your traffic, if a zone fails, you get only 6. So if you want to really have enough capacity to, even in case of a zone failure, to serve all of your users, you should provision extra VMs so that 2/3 of it, of the total number, is enough to serve the traffic. So in this example, for example, if you deploy, let's say, 6 extra VMs, even if a single zone fails, you still have 10 VMs, which is more than enough to cover your requirement of 9. And the way to calculate how many extra VM to provision is easy. You just divide the number of total VMs that you need to serve your workload by the number of the remaining serving zones. So for example, if you deploy your group to 3 zones, you need to provision 50% extra machines so that even in case of zone failure, you have enough machines to serve all of your traffic. So let's see how this works.
OK. So we have another managed instance group. This time that it's deployed in 3 different zones. You can verify it here that it's deployed in US Central 1B, C, and F. And in each zone, we have 2 instances that are running. I've also configured a load balancer that will direct traffic to all of the instances. So let's go open it up. And you can see that on each refresh, it should work. Just grab it one more time. Yeah, on each refresh, we get a VM that is serving from a different zone. So what I did is I wrote a simple script, regional test, that will just scrub the web page from each of the instance, get the zone that the instance is running in, and it will print the zone on the screen. So you can see that right now we have instances serving from all of the zones. So how to do a test on the how to test if the zone fails? So I cannot bring the whole zone down, obviously, but what I can do is I can simulate it by disabling health checks. Not disabling, start making our VMs report unhealthy from particular zone. So let's do that. Regional. Disable US Central 1F. All right. So what I did, as I told you, right now, VMs from zone F are starting to report that are unhealthy. So load balancer will notice it in a matter of seconds and will stop directing traffic. You can already see that we are serving traffic only from zone B and zone C. So let's also disable zone B. Few more seconds. All right, you can see that load balancer noticed it, And right now, we are serving only from zone C. So let's bring back all the zones back up. Sorry, US Central 1. All right, so all the VMs are reporting status the healthy. So load balancer pings each of the VMs, notices that it's starting to respond healthy, and it can accept traffic, and will start directing the traffic back to those VMs. You already see that zone B is up and running, and zone F will be available in a matter of seconds. Can we get back to the slides, please?
All right. So now we have a highly available application. We've protected it against application failure on a single machines and also against a more rare event of a whole zonal failure. But how about the problems when a load spikes? Or when you have a load going down and excess VMs that you don't want to pay for it? Autoscaling helps you with that. It maintains the group size tailored to the current load that your service experiences. Configuring autoscaling is easy. You set up the load metric on which you want to scale. A very popular one is CPU usage, for example. You set the target load, let's say 60%. You can also specify minimum and maximum number of VMs that autoscaler should not exceed. Minimum is useful if you want to have like the minimum capacity that you always want to be running. And maximum is to essentially cap your budget against scale up if you don't want to overspend. And also you need to specify a cooldown period. A cooldown, during the cooldown period, it starts when the VM boots and expires after the number of seconds you specify. Autoscaler ignores the signal from this machine. This is because on VM boot, the signal might not reflect the actual real-life load, as many of the boot processes can utilize CPUs more than usual. So make sure you configure cooldown period to a higher value than the VM takes to boot, so that your autoscaler takes only the signal that represents the actual load, and hence makes more accurate scaling decisions. So let's see how autoscaling works. Let's say you have 3 overloaded machines and the target load of 60%. Autoscaler will notice that it's way above the average load is way above the target, and will create 2 more machines to bring the average load back to the target. Now, if the load goes down over time, Autoscaler will notice again that the average is now significantly lower than the target and will remove the extra machines to bring it back to the target. That's how it works in a nutshell. And pro tip is that if you want to make sure that your workload scales up really fast, you should use a lower target CPU load. Like if we look at the example here, if you have 3 overloaded machines of, let's say, 80, 70%, and 90% utilization, if you set the target load of 60%, Autoscaler will scale the group size to 4 machines. And if you set the target load to a lower value, like say 40%, you will get 6 machines, which is a faster scale up. And one more tip, if you use autoscaling with regional managed instance groups, the same approach applies as for fixed size groups, which are not autoscaled. Make sure that you set a maximum number of instances to a higher value that is needed to serve your load, so that even if a whole zone failure happens, autoscaler has enough room to scale up in the other zones. The formula of calculating how much extra to set for the maximum is the same as for the fixed size MIC. The only difference is that in the fixed size group, you will have these machines always running, whereas in autoscale group, you don't have to pay for them. This is only a theoretical maximum that you allow your autoscaler to reach. So let's look at the autoscaling in practice.
OK, so we have one VM that is running the same web server application. So I told you that this web server has a few different features. So one was reporting healthy and unhealthy status. The second one is making the high load on the CPU. So what it does in the background is just multiplying two random numbers in a loop without any delay. So it's basically making the CPU being utilized in 100%. Let's look how our auto-scaling is configured. So we are looking at the CPU usage, and we want to have our managed instance group scaled to be below 50% on average usage of all the VMs. Minimum number of instances is 1. That's why you saw 1 instance up and running. And we have maximum number of instances set to 5, and cooldown period set to 30 seconds, which means that Autoscaler will not look at the CPU utilization for the first 30 seconds. Our application is quite small. It starts quite fast. But if you have very high intensive workload, for example, creating the cache or something else, you can put a bigger number here. So let's go back. OK, you can already see that. Can we get back to the to the screen? OK, you can already see that Autoscaler noticed that this first VM was overutilized and started to boot up additional VMs. If those VMs will be also utilized in over 50%, Autoscaler will schedule another VM creations and bring it up to number 5. Thank you.
All right. So now we have a highly available auto-scaled application. But how about updates? How do you roll out the updates automatically, but also protect your customers against bad pushes, which sometimes happens? Auto Updater allows you to do just that. But before we go into how you configure it, let's think about what an update is. In the beginning, you have an instance group in the old version. At the end, you want to have it in the new version. And update is a journey of how you get from the old version to the new one, as it takes multiple steps. And you can configure the journey with the following parameters. First, you can set up how many machines do you want to update. Maybe you want to update the whole group if this is an urgent fix. Maybe you want to do a canary update and update only part of it. So let's say roll out to half of the group to see how it works before proceeding. Second parameter is how many machines do you update at the same time, as the machines need to be recreated from a new instance template for an update. So this is your disruption budget. Third parameter is how many extra VMs in a new version to add temporarily for the update. This is useful if you don't want to take any of the old machines down, but keep them in service, and instead create the new machines in the new version, wait until they start serving, and only then take down the old ones. Finally, you can specify the minimum wait time, which is after the machines have been updated, how long to wait before proceeding to the next batch in the rolling update. You can also use recreate or restart actions for an update. Recreate is when you recreate it from the new instance template. Restart is useful when you use an agent inside a machine for an update and you need to restart to actuate that update with the same rollout logic as above. And finally, you can make an updater proactive, which means that it will do the rolling update automatically, or opportunistic, which means that it will only create new machines when they are needed, for example, when scaling up, and it will only delete the old machines when also it's needed, for example, if you resize the group down. And you can have even more fine-grained control over update. For example, which specific machines to update when, in which order, by setting the update for opportunistic, changing the instance template in the group, and then just recreating the machines that you want to update manually. And on machine recreation, they will pick up the new instance template, and you will get the new version. This way, you can be in the full control of the rollout if you don't want an updater to be automatic. So let's look at some of the common scenarios. Rolling updaters is the first one. So imagine you have a quick fix that you need to roll out to the whole group. So you set a new template to 100%. However, to stay on the safe side and not to disrupt the service too much, you set that the rollouts, let's say, 3 machines at a time. And if the update is good, updater will proceed with the next 3 machines. If it's bad, bad means it doesn't pass the health checks, the updater will stop, and then you can come and check out what's happening and debug, or maybe make a rollback decision. But if everything is going well, the updater will take 3 machines by 3 machines until the whole group is updated. And it will only proceed to the next batch of 3 once the previous 3 have passed the health checks. Another very common scenario is canary update. So imagine you have a web store and you roll out an update that is supposed to increase conversion to purchases. Of course, you're not going to roll out it to the whole group right away. You'll probably want to canary it, let's say, to 30% and wait for a while, maybe a week, maybe a month, to collect enough data to prove that the conversion is indeed improved, and roll it forward if that's the case, or roll back if it didn't happen. So let's have a look.
OK, so let's do both things at the same time, both things what Mykola said. So let's do a canary update in a rolling fashion. So we have 4 VMs. All of these are created from the instance template 1. Before I will start the rollout process, I need to tell you a few words about this application. It's a simple application that monitors the internal status of the VM. So it will show you when the VM will start creating, when it's going to be deleted, when it's restarting, recreating. And it will also show you the version of the template that it's used to create it. So you can see that we have 4 VMs running from instance template 1. OK, so now let's initiate the update. Let's say we want to have half of our fleet serving from new version of the application. And we'll also want to spin up one new VM at a time. So what it means that we will not exceed the number 5 of VMs that are running at the same time. All right. OK, you can see right now that the new VM is being created. It usually takes about 30 to 45 seconds for the process to be completed. So we need to wait a bit. Once this VM is up and running and managed instance group verify that it's created successfully, one of the older VMs that were created using instance template version 1 will be deleted. Once this VM, the deletion process will be completed, we'll spin up additional VMs, additional 1 VM. So you will see another bar with the green color, and the process continues. So right now you can see that the instance is created. It's created from the version template 2. So we have a new version application running on this VM. And once the process completed, the old VM, one of the old VMs was starting to be deleted. And as I said, the process will continue once half of the fleet will be served from the new version of the applications. Back to you, Mykola.
Yeah, and what's great to note is that when you do a canary update, let's say to half of the fleet, even if the group is auto-scaled, it will automatically maintain this ratio for you if you specify a percentage. But you can also specify a fixed number of VMs and canary 1 or 2 or 3 VMs as you wish. So another interesting scenario that is worth looking at is if you have a highly available workload that you really don't want to disrupt at all, but you want to roll out update as quickly as possible, you can set the new template to 100%. So you want to update the whole group. But you set max unavailable to 0 so that none of the old serving VMs is touched, and instead max search to 100%. So what's going to happen is that the group will create 100% more VMs in the new version, wait until those VMs pass the health checks, and only then remove the old version. So this way you get highly available update, but which is fast at the same time. So how does updater coordinate with the other automation services? Let's say updater and auto healing. You have specified that your disruption budget is 2, so you can update 2 machines at a time, take them out of service, and updater successfully did that. Now, as the updater is about to get to the next batch, one of the old machines fails. Auto-healing will detect that and will start recreating it. But will updater take down 2 more machines or 1 for an update? The good news is that updater is aware of the disruption and will respect your configuration of max enable 2 and will take only 1 extra machines down for an update so that your workload is still serving at the capacity that you can tolerate. And in the end, the 1 machine gets updated and another one gets auto-healed. How about updater in auto-scaling? Let's say updater recreates 2 machines from the new instance template. And of course, while these machines are being recreated, the remaining VMs will get a bit more traffic and the average CPU load will spike. Will autoscaler create extra machines? The answer is no. Autoscaler is aware that the machines that are being updated will be back up and running soon, so it will keep the group size at the same value, and once the machines are back, it will be serving again. How about updater in regional managed instance group? Updater will update the machines evenly across the zones to spread the risk, and once the new machines are up and running, it will also remove the old machines evenly across the zones, again, to spread the risk for you, for high availability. Finally, let's have a look at how updater works with the load balancer. So before taking and recreating a machine for an update, the machine will first stop receiving new traffic. Then it will wait for a connection draining timeout to drain the active sessions. You can configure it in your load balancer configuration. And only once the sessions are drained, updater will recreate the instance from the new template, wait until it becomes healthy, and after that, the new machine will start serving traffic. So the update is really very graceful and won't interrupt any of the existing connections. So there we have it. Managed instance groups allow you to build highly available, scalable applications that are easy to update automatically, and will take care of application failure with auto-healing, will protect your application against zonal failure by distributing machines across multiple zones, will also tailor group size to the variable load with auto-scaling, and also protect the updates from unhealthy new versions, but if the machines are healthy, roll it out automatically. So that you can have a peace of mind and focus on your more important tasks, knowing that your workload is taken care of. Now, let's have a look at the right size in your machines. We've talked about that it's not very easy to pick up the right shape for a machine. Of course, the shape that you have used back in your on-prem data center will work, but there are many more potentially possible combinations of CPU cores and memory that are available on Compute Engine, so how do you know that you don't overpay? The good news is that Compute Engine observes utilization of your CPU and memory on your machines over the 8-day period, which is good if your workload has weekly load patterns or more or less persistent load over time, and will recommend the optimal size for your machine if it thinks that the current size is not optimal, either for individual machines or for VMs in the managed instance groups that are not auto-scaled horizontally. And recommendation can be either save money if your machine is too big, or if it consistently sees that the CPU utilization, for example, is very high, it might suggest you to get a bigger machine to improve performance of your workload. And what's great is that we have the recommendations API already available in alpha, which allows you to get all of the recommendations from your projects programmatically via RESTful API. And then with that data, you can aggregate, triage, prioritize the recommendation as it makes sense for your organization, build dashboards, reports for your teams, visualize savings, and whatnot to help you manage the costs of your deployments. And one more pro tip is that if you want more accurate recommendations, use a Stackdriver monitoring agent on your machines, as it has a better visibility into utilization inside the machine, and as a result, will increase quality of the recommendations for you. So let's have a look.
All right. We have 5 different instances. So let's imagine that you have a virtual machine on your own data center, and you move it to the GCP, the Google Cloud, using the exact same size. So for example, we have a machine that has 4 CPU cores and 50 gigabytes of memory. But what happens if your application does not use this CPU power and memory? We'll detect it, and after 1 day, we'll give you the recommendation to size it down to save some money. So resizing the VM is very simple. You just click on the resize. You can customize the VM size. For example, if you know that your application will not even use 2 CPUs as we recommended, you can even scale it down to 1 CPU. And you click apply. So now what happens is we will automatically stop the VM, change the VM's shape, and start it up without you having to do anything else. But this is the one type of recommendation. So it's basically telling you size down to save some money. But what if you've created a VM, you've started the application, and right now the application is very high CPU intensive. For example, you have this web server application that is doing some batch workloads that are doing the computations. Again, we detected it. We can verify that there is a process that it's utilizing 100 of the CPU all the time. So we detected it, and we are saying basically your instance is underutilized, and you should scale it up. And you can apply the same recommendations in the same way. So click resize, change the number of CPUs or RAM, and be good. The same thing works for managed instance groups. So you can see that right now we have a managed instance group with 2 instances, and again they have low memory usage, low CPU utilization. So you can make it. You can change the instance template to the smaller one and save some money each month. Okay, so I will now show you how to quickly use the API. So this is a simple one-line code using curl that will just query the recommendations, and will basically get the same information that you've seen on the screen. So for example, here we can see that some information about the zone, and that will save $74 if we apply these recommendations. And using it, you can build, as Mykola said, a simple dashboard that will aggregate all information from all the VMs in your project, from all the projects that are created by you. For example, do the sum and give you the total savings per month from all the recommendations that you saw. Can you get back to the slide, please?
All right. So in short, right-sizing recommendations help you to save cost on your deployments, improve performance, and what's most important, relieve you of the pain to make the decision of what machine size do you have. There is no wrong decision. Even if the machine size is not optimal, recommendations will detect that based on the utilization that they observe, and suggest you a size that it thinks might be a better fit. So bringing it all together, we have looked at how to deploy application with the containers on managed instance groups. We've built highly available and scalable stateless applications on top of managed instance groups. And we have also looked at how to apply right-sizing recommendations to your VMs. And I want to leave you with this, that even if you have to deploy your workloads to virtual machines to have the full control over your infrastructure, you don't have to manage everything by hand. You can have highly scalable and available deployments by picking and choosing recommendations, as well as automated services such as auto-scaling, auto-healing, auto-updating that work for you. You are not on your own. Thank you. And just a quick reminder, don't forget to give the feedback on the session, which is available in your app.
All right.
All right. Thank you very
Thank
much.
you.